Hello, everyone. Welcome to Flutter Atlanta. My name is Emmett. I'm a Flutter engineering manager here at Black Airplane, where this is hosted. I have a background in native Android and iOS development, and I've been using Flutter for over 4 years. I've built over 20 Flutter apps and have several more in progress, and I love Flutter so much that I use it for all my personal projects. I want to give a quick shout out to Black Airplane for always providing food, beer, and an awesome place to host this. Black Airplane is a leading development agency in the Southeast, and we have a special team here that produce top quality work, and we're capable of building pretty much anything these days. So today we're going to be talking about test-driven development, and the reason we are revisiting this is 2 years ago I did a talk, and it's actually our most viewed one on the Flutter Atlanta YouTube channel with like 1.3 thousand-ish views now. And a lot's changed since then. I've learned a lot since then, and it seemed like it was a good time to update this talk. So our agenda for today, we're going to go over 6 major topics, which is what is test-driven development? We're going to take a look at the test-driven development lifecycle. We're going to talk about the types of tests in Flutter. We're going to go over some tips that I have for you when it comes to writing tests, and then we'll go over any recommended tools that we use, and then we'll open it up for questions and discussions. Cool. So first, what is test-driven development? Test-driven development is a process where you convert requirements to test cases before the software is actually developed. And then you will repeatedly test software against all of those test cases, and this will allow you to then write the minimum amount of code for the test to pass. So you're going to figure out what you're building, create acceptance criteria, write all of your tests, and then write code to pass those tests, and theoretically you'll have your feature done. So what is this life cycle? Again, first step, you're going to break down all of your requirements into tests, write all of the criteria before writing any other code. And then once you have this, you should have a list of all failing tests. So this is also known as the red phase. Write all of your tests, make sure they all fail, and then get to writing code. Once you've written all of your code, there's a chance that you're going to need to refactor it. And the best part about this is now that you have a whole test suite ensuring the functionality is working properly, you can refactor your code to organize it better and then compare it to the test suite to make sure everything is still working as expected. So what are some pros and cons of test-driven development? I just have a couple main ones here. The pro, why you should use test-driven development, is writing tests before your code can help you write better code and spot mistakes ahead of time. A lot of times when you see all of the various test cases before you write the code, you're able to ingest it different and have better foresight. So you're more likely to avoid silly mistakes when writing your code the first time. So while you're investing some time up front writing tests, it could help save you time actually writing the code itself. And then, of course, the best part about test-driven development, once you're done writing code, your test suite is going to give you confidence that you actually solved this problem properly. So instead of just writing code that you think works, you'll actually know it works, at least as good as you've written all of the tests and acceptance criteria. So what are the cons? Why you shouldn't use test-driven development? Test-driven development can take up a lot of time and slow down the progress of your project. And also at times, test-driven development can be too rigid when making changes or adding new features. Test-driven development works best when you are very clear about what the expectations are for a feature. And sometimes that doesn't go very well with agile development. Agile, the whole thing is we should be able to change directions all the time. How many times have you guys gotten into a sprint, gotten a ticket, started working on it, and then the acceptance criteria changes mid-ticket? That gets really difficult with test-driven development because you need to have very concrete expectations for every ticket. Awesome. So now let's talk about types of tests in Flutter. So there's 3 different major types of tests in Flutter. The most basic is a unit test, and this is going to test a single function, method, or class. You'll see I've copied from flutter.dev. They rank these tests on 4 different criteria, which is going to be the confidence that it ensures that it's working properly, maintenance level, and then dependencies, and then how quick it is to execute. So for unit tests, low confidence, it's testing a very small piece of the app, but they're very low maintenance. Once you write them, you probably won't have to change them too often. There's few dependencies because you're just checking one very specific piece of logic, and the execution speed is very quick. The second type of test is a widget test, and this is sometimes also referred to in other frameworks as a component test. and this tests a single widget. So these are going to be more like a UI-focused test. The confidence here is going to be higher because you're ensuring things are displaying properly on screen. But again, the maintenance is higher. You start changing how things look, you're also going to have to change these tests. Dependencies, there's more dependencies here, obviously, because we're rendering UI, but these still execute fairly quick. We don't need to run it on any special device or anything to actually run these tests. The last is integration test, and this is to test a complete or a large part of an app. This is going to give you really high confidence that that specific flow is working, but maintaining them can be very difficult. You have a ton of dependencies, including having to run this on a physical device. So you're going to need to pair this kind of system with a device farm, like a test grid, or Firebase has device farms, AWS has device farms. And the execution speed is slow because you're going to spin up a simulator or device somewhere, install the entire app, and then it's going to, as a person would, open it and tap through the flow. That's really what the integration tests here simulate. So, coming directly from Flutter.dev, generally speaking, a well-tested app has many unit and widget tests tracked by code coverage, and plus enough integration tests to cover all of the important use cases. So you're doing a good job testing your app if you have solid code coverage with unit and widget tests, and at least integration tests to cover your most major and important flows. Awesome, so let's go into some of my testing tips. First off, testing actually starts with writing tickets. Testing is significantly easier when everyone is on the same page. And what I mean by that is writing acceptance criteria can help align product, design, and dev. Once you're in a larger company, we all need to be on the same page about exactly what we're building. And all three of these segments are going to have different needs. Design is going to want to design it a certain way. Product is going to have certain requirements on the user. So when we're all together and we can decide on the acceptance criteria, it just gets everyone on the same page. And also, acceptance criteria can give the dev a good starting point on what tests they should write. I'm not saying the acceptance criteria should be one-to-one to the tests, but there should be a test for every piece of acceptance criteria and then some that the dev would add in addition to that. Next, I want to talk about test structure, and this also goes towards writing tickets. This is called like the given, when, then method, and just following a consistent structure for writing your tests is going to allow you to be more organized and more readable for anyone jumping into the project. And an example of this would be something like given a logged in user, when they do an action or tap the logout button, then do something like sign them out and redirect them to the sign in page. So when you're writing your tickets, if all of your tickets have, an overall goal and then a whole bunch of acceptance criteria written like this, it's going to be very easy to write tests against this. And also going hand in hand with that, you have, I call it an AAA test, which stands for arrange, act, and assert. And this is a code snippet of just a very basic one. And essentially, you'll see that given, when, then, describing what we're testing. And then there's always three main sections of a test. In this case, you're arranging. This is where you're going to set up everything you need to run the test. The act, which is going to do that one action that you're testing. And then assert, which is making sure you got the result thereafter. So by having the simple given, when, then, and then arrange, act, and assert, any developer could come in here, see that all the tests are written like that, and be very at home with modifying, understanding, all sorts of tests. Next up is code coverage. Tracking your testing is really important. So code coverage is basically a metric that helps you understand how much of your code is tested. For example, an 80% code coverage is roughly 80% of the lines in your code base are ran during tests. So if you ran your tests, 80% of the lines are covered because they were executed during a test being run. But it's very important, this is not an indicator of code quality. I could write a test that doesn't really do anything and it just runs a whole bunch of lines and get a really high code coverage. So you need to, through PR review and education of your team, make sure that people are actually writing really good tests. Next is CI/CD. We've done a couple talks on this specifically, but we need to mention it here as well. This is all about enforcing your test suite. It doesn't make sense to write all of these tests if you're not going to enforce them for every user. So CI/CD stands for continuous integration and continuous deployment, and it enforces tests to pass before new code can be merged. This helps you utilize the test and also protect you against any new code written. The next one is going to be accessibility tests. And in addition to this, really it's just utilizing Flutter's pre-made tests or testing systems. So keeping up with WCAG accessibility standards can be pretty tough, but Flutter has made some pre-made tests that you can utilize to check for some of these requirements. These are going to be things like making sure all the tap targets on the devices are of a proper size, making sure the text contrast is all up to standard, and also making sure anything tappable has a label to help with screen readers and things like that. In addition to this, I want to point out if you're using a state management system like Block, you should also utilize their testing framework specifically for it to make your life better. Don't reinvent the wheel here. Utilize pre-made tests and pre-made testing tools when you can. Awesome. So let's go through a couple of our recommended tools. First, of course, is Code Magic. We recommend this on every single CI/CD related talk we've done. We've had the CEO come on Flutter Atlanta and answer some of our questions, which is really cool. And this is a purpose-built Flutter CI/CD tool. You have the capability to write workflows with YAML if you're a pro at setting up CI/CDs, or they also have a really nice UI editor where somebody that has no experience can go in and set it up just by modifying some different variables. So absolutely great. They do have generous free tiers, and it integrates with GitHub nicely as well, so you can see just like a GitHub action, you can see all your builds running, everything right there. Next is Test Grid. Again, if you are writing integration tests, the only way to really enforce those is to have some sort of testing framework or device farm. So that's really what Test Grid is for. They have all sorts of different devices with the latest browsers, old devices, everything you could think of. So making sure that your app is running across a huge amount of devices can be really useful, especially depending on the size of your app. So Android specifically, obviously iOS only has a couple models here or there. Android, though, has like thousands and thousands of phones and some that we haven't even heard of in the US. So if you start seeing crashes or specific issues with devices, Test Grid will allow you to spin up something like that and run it on there with your integration tests. Next, this is a tool very similar, and you can also use the one that Cardin used in his testing talk called Full Coverage. But this one's called DLCOV, and it's mainly meant to give you an accurate reading of your code coverage. So the way Flutter works, if your tests don't reference a specific file at all, it just won't be included in the coverage. So you'll get a false coverage number. An example of where this could be really bad, let's say we had a project with an 80% code coverage requirement, and then somebody went and made a PR, but their PR wasn't referenced by tests at all. They might have written a whole bunch of new code, but it just wasn't referenced by any tests. So they're actually able to get that merged in without having to write very many tests at all, and they're still going to pass the code coverage because it doesn't recognize that there. So this tool allows you to automatically generate files that make sure everything gets covered, so it gives you a true full code coverage number, and it has some other nice command line arguments, like at the command line being able to pass or fail if you hit certain coverages and things like that. Next is going to be a tool called Patrol. It was made by Lean Code, who is very active in the Flutter community. Integration tests are great and very powerful, but Flutter is limited in the sense that it makes it difficult to interact with native features. So what Patrol does is all in Dart allows you to interact with native features like closing native dialogues, notifications, web views, changing device settings, all like that, all through Patrol written in native Dart in your integration tests. So if you're taking integration tests really seriously, this is probably something that you want to pull into your project. Next is going to be CodeCov. This one's free for open source and very affordable for any private projects. But essentially what this does is you're able to send your code coverage reports to this tool. It's going to give you a nice badge displaying your code coverage in case this is open source. People do care about that. And then also it gives you nice graphs breaking down which files are covered, which ones aren't. It can block PRs if they're not hitting a certain coverage, all sorts of things like that. And then I believe last is Mocktail. Again, when you're writing tests, you're going to have to mock dependencies. When you're testing something that has dependencies, you don't want that test to be relying on if those dependencies are working properly or not. That should be their own tests. So with Mocktail, you can mock a whole bunch of dependencies, and then you can assume they're working in your tests. Mocktail is also similar to Mockito. Mocktail, I just like the interface a little bit better when writing tests. So definitely one to check out. And that's it. Any questions? Brandon.
How come, I mean, obviously this is super important. How come developers don't do it?
It's kind of painful and tedious. And if you don't have a lot of testing experience, then it feels like it takes a lot of time and you're not getting an outcome from it, right? When you write code, you're getting an outcome from it that you can see. When you're writing tests, you're just ensuring the code you're about to write works. So if like you're a solo shop and you're just trying to get something out quickly, a lot of times it doesn't make sense to waste that time. Now, if you're doing a lot of testing and you're really good at writing testing, then it might not slow you down at all. It might just become part of your workflow.
How do you personally in your team here at Black Airplane, how do you balance, I know we don't have 100% all the time every project, but how do you balance actually writing code, writing documentation that scales with the app that we're writing and makes it good for our customer with test coverage as well, while being a good steward of the client's time?
Yeah, I think the biggest thing you can do is you have to isolate the most important parts of the app, right? So if we shipped this app and one of these core features was broken, how detrimental would that be? If we ship an app and users can't sign up, very detrimental. We need to make sure we have test cases around that to make sure that that never breaks. If we have a QR scanning app, we need to make sure the QR scanning always works, right? So we should write test cases around that to make sure that works. So you don't necessarily need to test everything, especially here in agency life. Again, it kind of depends on the customer's requirements and how they want to spend hours, but you generally should at least test the most important parts of your app because you can't afford for those to break. Any questions? Good. Let me see if you want to read them so I don't have to pull it up on screen.
Yeah, Randall says, also look at package GLaDOS for property testing.
Property testing.
Oh.
I haven't heard of that.
Yep. So this goes back to if you're going to use pre-made tools for your testing, don't try and reinvent the wheel. So there's a lot of different testing tools out there. Again, this is going to be similar to like a patrol or something, how it's assisting you with the integration test. This would be assisting you with the property test, trying to make it easier to write.
He said it's used heavily by FP Dart.
Yeah, which is another popular package.
He said also have AI write some of your tests. IDX can let you try Gemini writing tests.
Yep. Yeah, again, AI, some people love it, some people hate it. I think it can be useful for writing some base case tests, but it should be there to speed you up. It should not be there to do the job because there are so many times where it spits out something wrong. And if you're given real acceptance criteria for a ticket and you just let it write all the tests and you don't actually write tests for acceptance criteria, then it's not going to. So just make sure you double check and understand the code that AI is providing for you.
I still have not had a lot of luck with AI writing Flutter tests.
Yeah.
I don't know if there's just not enough examples out there, but it'll do, like you said, the simple stuff, but some of the more complex.
Are you using Cursor, ChatGPT, or do you, maybe the model is a better way to go off of this?
It could be the model difference. Maybe Claude or something would be better. I'm using just GitHub Copilot.
Okay. Yeah, I have pretty good success with Cursor and Claude. It's cool because you can like go to a file and then just at the file and say, write tests for this file. And it does a decent job. It doesn't always work. Again, like most of the code it spits out needs some sort of modification, but gives you a good starting point.
Okay, cool.
This is a ignorant sales was a brain question, but what is I've heard regression testing thrown out. Is that different from these tests?
It kind of depends on the context that it's used. So the idea of regression testing is we at one point had an app that we knew everything worked. And then we went and made a huge amount of changes. And now we need to make sure that we didn't break anything. So with that, depending on your test suite and how the test suite gets modified over the duration of that code change, it should be able to protect you from any old things regressing back in. But, you know, it's a great theory, but if all the tests change while you're doing the code change as well, then that's not super helpful. Normally, like what I'm seeing at our companies that we work with, when they do a regression test, obviously all of the integration tests we have and our automated tests will be passing already. So that's when a real QA team will come in and themselves go through and check all the flows to see if they see anything wrong. There's in the real world, there's too many cases to write tests for.
Randall said, I think in regard to your conversation, he said that Gemini is better at writing tests for Flutter. He said IDX is specifically supporting Flutter, so it's better.
Oh, cool.
It would make sense for the Google model to be the best at writing the Google code.
That's fair. I'll have to give it a shot. Is it any codes? Free codes?
Yeah.
Is there any difference in testing for mobile versus testing for web, or is it all just testing?
Yes. So you can in your tests themselves, like your widget tests. For one, you can set like the canvas size. So if you could probably write a test suite to run all of your tests on different devices if you want to, like in the widget tests themselves. Integration tests, you would obviously have to find a way to run your integration test against a browser type situation. So there's a lot of considerations that would come in with web.
I forgot. Does Flutter support running tests on a browser yet?
I'm not sure if they have integration tests in the browser. But I will say there's still ways to use more traditional tools. So like accessibility is supported on web. And a lot of these tools that are out there that do automated testing actually go off of accessibility tags to find things. So you can write a full integration test off of accessibility tags. So if you can do that, you could use a tool to run an integration test. It just wouldn't be like through Flutter's ecosystem.
Got it.
What are the when you talk with a junior developer or you're getting them up to speed in some of these principles, what are the big pitfalls that you see them fall into? Just not doing it.
Well, it's more writing tests takes a different mindset than writing code does, and it's also like pretty tedious. Like for whatever reason, it's not a good feeling to sit there for 3 hours and write tests, but it's a good feeling to sit there and write 3 hours of new code. It's one of those things. It's like working out. You have to make yourself do it, right? Any other questions?
That also makes you write better code.
Yes, it does. Yeah.
When you have to test it, you're like, I gotta make this efficient,
Yeah.
easy to test.
You have to push yourself to think of the edge cases more than anything. So it's like it'll help your debugging skills as well.
Do you write tests for obviously functionality? The app should be doing this. Can you write tests for performance as well? Like it should do this in X amount of time?
Yeah.
That's a good question.
Yeah, you could do that. So like you would probably write like a unit test, for example. Let's say I had some really complicated function that's going to do something. You could basically time how long it takes to run that function and then expect that it's going to take less than a certain thing. But that's probably not wise because you have no idea what types of machines you're going to be running your tests on, right? Like if it goes on a Mac Pro, of course it's going to take a super small amount of time. But the Flutter out of the box comes with a debug system, so you can look at the memory graph and stuff like that. And there's tools out there to report to Firebase performance metrics, like how much memory is being used, what are load times, all of that. So that's probably more of a gather in real time. If we need to speed this up, let's speed this up versus writing tests to ensure it. Now, I'm sure that Google has a way to do that, like with their search engine, search times were so crucial. I'm sure they have built a system of some sort that could test performance metrics before things get pushed. I imagine that's some sort of integration test. Cool. Awesome. Thank you for everyone tuning in online, and we'll be back.
Next month, Danielle is going to be talking about Vertex.
Danielle talking about Vertex AI next month.